Hello, this is Mr. Stansbury. I'm going to take you through the 11D assignment. Okay, so we're going to start here with number 2. So we've got a square carpet has an area of 64 square meters. Find the length of its side. So since it's square, we know that it's going to be, say, x by x. So the area of a square is going to be x squared. So we know x squared equals 64 square meters, so we square root both of those and we get x equals 8 meters. Okay, so for part B, a postage stamp is 3 centimeters long and its area is 5.4 centimeters squared. So let's say that this is 3, and then we know that the area is 5.4 square centimeters. We got to figure out what the x is, right? So we know that 3 times x equals 5.4 square centimeters, right? So if we divide both sides by 3, that should tell us what the other length is. Okay, so let's pull up our calculator. And we've got 5.4 divided by 3 gives us that x is 1.8, and that's going to be centimeters. Okay? All right. Next one, number 4. A rectangle of lawn is 30 meters by 25 meters, as shown here, and has a 1 meter wide path around it. Draw a diagram and find the total area of the concrete for the path. So what they're saying is there's this little walkway around this whole thing here. So there's a 1 meter wide path that goes all the way around this lawn. Find the total area of concrete for the path. So let's say if this whole thing here is 30, but now we have, again, this is not a beautiful drawing, but you get the idea. This whole thing here is 30, but we also know that this is 1 meter from here to here, and also 1 meter from here to here. This length of this piece of the path right here and this piece of the path up here is going to be 30 plus the two 1 meter pieces. So 30 plus 2, that's going to be 32 meters. Okay, and it's 1 meter wide as well, so 32 meters by 1 meter gives us that's 32 square meters for this and for that. So this section here is 32 square meters, and then this one up here is going to be the same. So we do 32 times 2 gives us 64 square meters. Now that's for this red area here and for this red area here. Okay, so then now we got to figure out these two sections here. We'll outline those in green. Okay, so that's that by that. This is actually pretty nice because this is just 25, and then this section here is also 1 meter wide. So for the green pieces, we just do 25 times 1, which is 25 square meters, but we have 2 of those, so it's 25 square meters times 2, or let's do this, just like we did up here, equals 50 square meters. So this plus this is 50 square meters. So we have, for the red, we have 64 square meters, and then for the green, we have 50 square meters. We add those together, and we get, let's see, 114 square meters total for the area of the concrete for the path. Okay? Okay, let's move on to the next one then. What's the cost of laying instant lawn turf over an 80 meter by 120 meter rectangular playing field? Turf comes in 1/2 meter wide strips and costs $15 for 10 meters. Okay, so first off, let's figure out how many square meters we're going to need. Okay, so this is 80 by 120, so this area in here is just going to be 80 times 120, right? So we do 80 times 120, and we get 9,600. So this is 9,600 square meters of turf that we're going to need. Okay. Now the turf comes in 1/2 by 10 meter long strips by 10 meters. So the area of this here is going to be 0.5 times 10, which is 5 square meters. So each strip is 5 square meters. Okay, so we have 9,600 square meters to cover, and each one of those strips is going to be 5 square meters. So if we take 9,600, divide that by 5, we get 19. We need 1,920 strips of grass, right? And then each one of those strips is $15. So we take 1920 times 15, and we're going to get our total cost. So times 15 gives us, that's a lot of money, $28,800 just for the strips. Granted, it is 80 meters by 120 meters, which is basically like a football field. That's even bigger than probably most football fields, but pretty close to. Anyway, that's a lot of money. So anyway, moving on. Number 7, the swimming pool question. Okay, this is a good one. This one it has you figuring out all sorts of great stuff on here. So, swimming pool has dimensions as shown over here, and it's to be tiled with tiles which are 25 centimeters by 20 centimeters long. So little rectangular tiles. Tiles cost $21.50 a square meter. Find the area of side A. So here's side A. Okay. Here's what I think is going to make this a lot easier to figure out. Well, really, you could look at this as a trapezoid, because there's the top and the bottom. Like these two bases are the same, are parallel. They're not the same. But you have those. But honestly, I think for most people, it's going to make more sense if we take this thing here and we split it into a rectangle and a triangle. Okay, so if we do that, and if I kind of redraw it here, we've got, and I'm going to just redraw it with, not quite to the same scale that they have here. But if we have this, so here's our rectangle here, and here's our triangle there. So this rectangle up here is 10 meters long. And if this whole length here is 2 meters, we know that this top piece up here is 1 meter. If this whole thing is 2 meters, then that also makes this down here 1 meter. Okay? So, and we know that this is 10.05 for this here, which for the area's sake is not going to help us. So I'm just going to kind of leave that off. So for A, the area of the rectangle, so let's do that in area of the rectangle up here is going to be in red. So that's going to be 10 by 1, which is 10 square meters. And then we've got the area of the triangle, which we'll do that in green here. That's going to be 1/2 the base, which we'll call 10 or 1, it doesn't matter. 1/2 of 10 times the height, which is 1. So half of 10 is 5. 5 times 1 is 5 square meters. Okay, so that means the total area for that triangle over there is 15 square meters. Okay? Excuse me. B, find the total surface area of the 4 walls and the bottom of the pool. So, the nice part is we just figured out this wall here. We'll call that the front wall. And then the back wall should be identical. Okay, so if we're doing, let's do B over here. So we've got front, back. We'll do the left wall, the right wall, and didn't say we have to find the bottom, right? And the bottom. Okay, so we'll just fill in each of these as we figure them out. So the front we already figured out is 15 meters squared. The back is going to be the same. That's also 15 meters squared. This left side over here is going to be a rectangle. So let's redraw this here. This is the left. Okay, so this height right here we know is 2. And this distance across is going to be the same as this, which is 5. So the left is going to be 2 times 5, which is 10 meters squared. Right? The right here is, again, there's just a 1 meter by 5 meters. So this is 1 by 5, which is 5 square meters. Right? So the right is 5 square meters. Excuse me. And then the bottom, if we redraw the bottom, we've got, let's see, we've got the whole thing tells us that the bottom is 10.05 meters across, just like that. And then its width there is going to be 5. So this is going to be 10.05 times 5. Let's break our calculator out for that one. 10.05 times 5 gives us 50.25. So this is 50.25 square meters. Okay, so to figure out the total surface area of the 4 walls and the bottom of the pool, we just need to add those all up, right? So we've already got the 50.25 on there, plus 15 plus 15 plus 10 plus 5. That's all 5 of the areas there. We get 95.25 square meters. Okay, so that's the total surface area of all of the pool that needs to be tiled. Okay. Part C says how many tiles are necessary for 1 square meter of coverage. So we know that let's see, we've got 25 by 20 centimeters. So let's turn this 1 square meter into centimeters. So 1 square meter is equal to how many square centimeters? So King Henry died unexpectedly drinking chocolate milk. So to go from units to centimeters, we got to go over twice. So we'd have to go over 2 times. But remember, this is meters squared, so we have to double that. So we have to go over 2 more times. So that's going to be 1 with 1, 2, 3, 4 zeros after it. So it's 1 square meter is 10,000 square centimeters. Okay, so let's figure out what each one of the tiles is going to be. That's 25 by 20, and that's going to give us 500 square centimeters, right? So then we got to take 10,000 divided by 500 is going to be, let's see, those go out. 100 divided into 5 is going to give us 20. So we need 20 tiles per square meter. Okay. How many tiles are necessary for 1 square meter of coverage? 20 of them. Okay. Part D says how many tiles are necessary to complete the task. So really we just need to, we've got our total surface area. So that's 95.25 meters, right? And then we need 20 tiles for every meter. So multiply that by 20, and that will give us the total tiles needed, right? So let's do 95.25 times 20, and that gives us 1,905 tiles needed. Okay, so that's D. And then E, what is the total cost of tiling the pool, given that adhesive costs $2.35 per square meter and labor costs $22 per square meter? Okay, and then the tiles cost $21.50 a square meter. So you know what? Let's just make this easy. Let's just add all 3 of these together, and that will give us the total cost for adhesive, labor, and the materials. Well, I guess adhesive is part of the materials, but that'll give us the total cost per square meter to tile it. So let's try that. So we'll do 2150 plus 235 plus 22. Okay, so that's going to give us, let's figure that out, 21.5 plus 2.35 plus 22 gives us a total of 45.85 per square meter. So 45.85, is that right? 45.85 per square meter. Okay, that's how much it cost. And let's see, what's the total cost of tiling the pool? So that much per square meter, and we know that there's 95.25 square meters, so we take 95.25 square meters times 45.85 meters squared, and that's where your meters squared go away, and that is going to give us the total cost. Okay, which is going to be a doozy. Let's see. So we got 45.85 in there already. Multiply that by 95.25, and we get $4,367.21. 4367.21 to tile that whole pool. Which, you know, I mean, that's a pretty big pool. That's 30 feet by 15 feet. It's not terribly deep because it's only 3 feet. It's only 6 feet at the end. But still, 4367.21 to tile that whole pool. That's a lot of money. Okay. Moving on. Number 9, Pete's Pizza Bar sells 3 sizes of pizza. The small pizza supreme is 15 centimeters across and costs $4.20. Medium's 30 centimeters across, costs $9.60, and the super size is a diameter of 35 centimeters and costs $14. Which of the pizzas give the best value? So what we're going to want to do is basically figure out how much you get per for the area of each of your pizzas, right? So let's see, we've got the small, which is 15 centimeters across, so that makes the radius 7.5. So the area of this pizza is going to be pi r, let's see, area for a circle is pi r squared, right? So this is going to be pi times, and then our radius we just figured out is 7.5. So pi times 7.5 squared is going to be the area of this one. So we try that one out, and we've got pi times 7.5 squared gives us a total area of 176.7, and that is what, centimeters squared, and then that costs $4.20. Okay, so let's figure out how much money it costs per square centimeter. So if it's dollars per centimeter squared is what we're talking about, then let's put the dollars. So we'd have $4.20 per 176.70, and that's our centimeters squared. So let's figure that out. So we take 420 divided by that 176, so let's just do second answer, and we get that we're getting this at what, 2.37 cents per I guess that's 2.38 cents per square centimeter. Okay, so that's for the small. For the medium, a little bit bigger, this one has got a 30 centimeters across. So if that's 30, then we know that half of that is 15. So we'll do area equals pi times 15 squared to figure out the total area of that one. So we've got pi times 15 squared gives us 706.9. square centimeters, and that costs $9.60. Okay, so again, we're going to take $9.60 and divide it by 706.9, right? Because that's our dollars per square centimeter, how much it costs for every square centimeter. So there's our 706 is already there, so we just do 9.6 divided by our answer, and we get, now it's 1.36 cents per square centimeter equals 1.36 cents per centimeter squared. Okay, so right now the not the small, but the medium is definitely a much better deal than the small. And then let's see what the extra jumbo one is. What's this one called? The supersize. Diameter of 35 centimeters. So that's really not a lot bigger. If you take 35 and divide it by 2, that's going to give us 17.5 for our radius. So 17.5. So this is going to be pi times 17.5 squared. Right, so we'll do pi times 17.5 squared gives us 962.1 square centimeters in pizza. So then we're going to take our total cost for that, which is $14. $14 divided by 962.1 square centimeters, and that's going to give us our total cost per square centimeter, right? So we take 14, divide it by our answer, and we get 1.46. 1.46 cents per square centimeter. So the one that you have to pay the least per square centimeter is going to be the best deal, so that is going to be the medium pizza. Okay, that's going to be, that gives us our best value. Okay? All right. Let's take a look at the next one. This is our last one. 10. The diagram shows a room to be painted twice, including the ceiling. The door is 0.8 meters by 2.2 meters, so let's write that on there. 2.2 meters by 0.8 meters. The window is 183 centimeters by 91 centimeters, so that's back there. Door also has to be stained on both sides with 2 coats of stain. Use the following table to calculate the total cost of stain and paint. Okay, so we're going to need to figure out the, let's see, the room, including the ceiling. We're going to paint the ceiling. Okay, so we got to figure out the total, let's figure out the total surface area that we need to paint. Okay, so that's going to be, let's see, the front is 4.2. So let's do this. We'll do front and back. So that's this one here and that one there. And that's going to be 4.2 by 2.4. The left and right. And so that's going to be this here. That's going to be 2.4 times 3.5. 2.4 times 3.5. And then the ceiling is going to be, 4.2 by 3.5? Okay. So the front and back, we're going to want to double those because that's just for one side, and the left and right, we're going to want to double those, and there's only one ceiling, so that's all we need for that. So let's calculate what all these are going to equal to. So that would be the total paint, and then we'll have to subtract the door and the window out, right? So we got 4.2 times 2.4 gives us 10.08, and multiply that by 2, and that's 20.16. Okay, and then we've got 2.4 times 3.5 is 8.4, and we double that, and we get 16.8 for the left and the right. And then the ceiling is going to be 4.2 times 3.5, which is 14.7. Oops. 14.7. So then we add those all up. 15, 6, 1 there, add a 1, 2, 3, 4, 5. 5166 square meters, right? But again, we got to take the door off and the window off. So the door is 0.8 times 2.2. Okay, so clear. We got 0.8 times 2.2 is 1.76 square meters. And then the window they give us in centimeters. So we have, let's do the window over here. So it's 91 centimeters by 183 centimeters. So King Henry died unexpectedly drinking chocolate milk. To go from centimeters back to meters, we got to move the decimal over twice. So that's 0.91 and 1.83. So 0.91 and 1.83 meters. So 0.91 times 1.83. So 0.91 times 1.83 gives us 1.67, we'll call it, square meters. So we got to add those two together and take it away from the 51.6, right? So we'll take 1.76 plus 1.67, 3.43. Okay, so then we're going to take 51.66 minus 3.43. 51.66 minus 3.43 gives us 48.23 square meters to paint. Okay, now the thing is we actually have to cover everything with 2 coats. So we got to take that 48.23 and multiply it by 2. So 48.23 times 2. We need enough paint to cover 46 square meters. Okay? So if you'll look here, we've got the we can either get a 4-liter bucket of paint that covers twice as much as the 2-liter, but it doesn't quite cost twice as much. So we want to get as many 4-liter buckets as we can, right? So what we need to do now is take our 96.46 and see how many. Let's see, that's it covers 16 square meters, so divide that by 16 and see what we get there. So divide that by 16 and we get that we need 6.02875, so 6.029 buckets of the 4-liter buckets. So that really means we need 6 4-liter buckets, right? And then we're going to have just a little bit more that we need, so let's just buy a 2-liter bucket with that, because if we bought another 4-liter bucket, we'd end up spending an extra $12 basically for that, right? So we need 6 4-liter buckets, and we need one 2-liter bucket. Okay, so sorry, I'm kind of working down and over here to the right. We'll probably finish up over here, but so 6 of the 4-liter bucket. So 6 times 32.45 will give us 6 times 42.35. Oops, that's not it at all. Tried to remember 32.45. There we go. Is 194.70. Right, and then we're going to add on one 2-liter bucket, so we're going to add 20.80 onto that, and that's going to give us 215.50 total in paint. So that's the paint total. Okay, so that covers all of that. And then the only other thing we have to do is figure out the door, right? So we figured out already that the door is 1.76 meters squared. You got to stain it on both sides with 2 coats. So we have 1.76, and we have 2 sides of that door, and we got to cover it with 2 coats. So that's going to be 1.76 times 4. 1.76 times 4 gives us a total of 7.04 square meters that we got to cover, right? So let's see, if we got 7.04 square meters that we got to cover with that, we should probably buy the 10-meter bucket, right? Okay, for $23.60. So we've got our $215.50 for paint, and then we need to buy a 2-liter bucket of wood stain. So stain is going to cost us a total of $23.60. All right, so we add those up there, and we end up getting $239.10. Okay, and that is our total cost for the whole shabam. Okay, so really that's all there is for this section here, this 11D. If you have any questions at all, please feel free to ask in class. Thanks.